All right, so we are going to be talking a lot about rational functions. We've been talking about polynomials, how to find their zeros, how to factor them, how to graph them, their end behavior, their local behavior. We're going to do similar things now about rational functions, okay? Rational functions are just two polynomials put together, right? They have a polynomial in the numerator and a polynomial in the denominator, and the big problem is where the denominator is zero, right? We cannot have the denominator be zero. So let's talk about some rational functions. First, let's talk about the domain, right? The domain we can't let the denominator be zero, right? The domain of a rational function includes all real numbers except those that cause the denominator to equal zero. So if we had this function x plus 3 over x squared minus 9, where can the denominator be zero? Well, we set the denominator equal to 0 and solve that polynomial. We've been practicing that a lot lately, so we're good at solving polynomials, finding zeros of polynomials. This one's going to happen at plus or minus 3. So the domain is all real numbers except plus or minus 3. And this is kind of a preview, a foreshadowing of what we're going to talk about. What happens at those two places? Well, sometimes you get a vertical asymptote, and sometimes you get a little hole in the function. Okay? All right, so let's talk about those two things, vertical asymptotes and removable discontinuities. We've already talked about vertical asymptotes. So what is a removable discontinuity? It happens in the graph of a rational function at x equals a if a is a 0 for a factor in the denominator that's common with a factor in the numerator. Okay, so let's just go back to that function on the last page. And we'll notice the factors of the denominator here are x minus 3, x plus 3. X plus 3 is in the numerator as well. We could kind of cancel those out. So at that 0, we have a removable discontinuity. Okay. At x plus or x minus 3, we couldn't cancel that out with the numerator. So we have a vertical asymptote there. That's what this whole thing is saying. Okay, you can read the whole thing, pause the video, read the whole thing. All right, so how do we find vertical asymptotes and removable discontinuities? First, we factor the numerator and denominator. We note any restrictions in the domain. We reduce the expression by canceling common factors. We note any values that cause the denominator to be 0 in this simplified version. These are vertical asymptotes. Note any restrictions in the domain where asymptotes do not occur. These are removable discontinuities. All right, so let's practice. Here we've got a rational function, and we want to find vertical asymptotes and or removable discontinuities. Well, first thing we need to do is factor the numerator and denominator. Oh, just did everything at once here. So can we factor this? The numerator we can't factor over real numbers. Denominator we can factor. And for some reason they wrote it in this weird way. I would probably write this as minus x squared minus x plus 2, and then factor it as x plus 2 minus x plus 1. Anyway, at any rate, they did it in this order. And we can see, can we cancel anything out with the numerator? No, we can't simplify this at all. So at -2 and at 1, we're going to have vertical asymptotes. At -2 and at 1, the red and orange lines, we've got vertical asymptotes. Okay, and sometimes the graphs can get kind of exciting. We've got like 3 different parts to this graph, right? You're going to be able to graph those in just a little while. But for now, we're just looking for the vertical asymptotes of this graph, and they happen where the denominator is 0. We couldn't simplify that at all. What if we have this function? Let's find the vertical asymptotes and removable discontinuities of this function. Okay, first thing we do is factor numerator and denominator. Got a difference of squares, we got a quadratic we can factor. All right, and now we look and say, aha, x plus 1, I can simplify that, right? That's a factor of both the numerator and denominator. So I simplify that, whoops, before I give it away. Here, there's going to be a removable discontinuity at -1. For this factor in the denominator, at x equals 3, I can't get rid of that. There's going to be a vertical asymptote there. So sure enough, at x equals 3, we see this red line. There is a vertical asymptote. And at -1, there's a removable discontinuity, which is just a little hole in the graph. The graph just keeps going merrily on its way like you'd expect. There's just one infinitely small point exactly at -1 where the graph is not defined, where the function is not defined. All right, let's do this one. Why don't you pause the video and see if you can do it. Find the vertical asymptotes and removable discontinuities of that function. All right, welcome back. I'm sure you did that, right? Pause the video and tried it yourself. You still have a chance. All right, let's factor the denominator. All right, it's a difference of squares, x minus 2, x plus 2. These we can cancel out. There's going to be a removable discontinuity at 2 and a vertical asymptote at -2. Let's look at the graph. Sure enough. Removable discontinuity at 2, vertical asymptote at -2. All right, and yep, that's the end of this section. So that's how you find removable discontinuities and vertical asymptotes.